Great, welcome back to grade 7 math. We are now looking at trapezoids, and trapezoids are really cool. They're just a little bit tricky because they're a weird looking shape. So as you can see here, we have a trapezoid that's down here. It kind of looks like a triangle with its head chopped off, but it's a pretty cool shape. And so let's just define what it is. Well, by looking at it, we can see that it's a four-sided shape, and so that makes it a quadrilateral. So a trapezoid is a quadrilateral. Now, what makes it so special, though, is that it does, just like a parallelogram, it has some parallel sides on it. But unlike a parallelogram, the other two sides do not have to be parallel. There are some definitions of trapezoids which state that they cannot be parallel, but some say that they can. So for our purposes, it doesn't really matter which definition, but we'll use the definition that it's a quadrilateral with only one set of parallel sides. Although this definition is up to debate. But let's just use this one. So that means we have one set of parallel sides. If you want to remember, parallel means that these lines will never cross. So we can continue on the top and the bottom of this trapezoid and it will continue forever. However, the other two sides, the ones on the left and the right, if I extend them up or down, depending on the trapezoid, they will eventually cross. And so that's what defines then a trapezoid. Let's just label then the different parts of the trapezoid. It's very similar to the parallelogram that we were looking at. We do have a base, but in this case we have two different bases because they're different sizes. In the parallelogram, everything was the parallel sides were equal to each other. In this case, they don't have to be. So this one we'll actually call the big base. I'm going to use the letter capital B the capital letter B to represent the length of the big base. And then I have the other base, because it's smaller, I'll call it the small base or the little base, and I'll use the small letter B. Just like in a parallelogram as well, we can also identify the height of a trapezoid. And this is still a 90-degree height, so please indicate the 90-degree angle at the bottom. That means this is the shortest distance between the two bases. This is the height. We also have our sides, but for the purposes of calculating area, we won't be using the sides. They are important, however, for the perimeter. So just like in any shape, in any polygon, I can find the perimeter by adding up or finding the sum of all four sides. And just like with any other shape as well, that if you find the perimeter and you're adding up the sides, the unit stays the same. Centimeters plus centimeters plus centimeters plus centimeters still gives the length, which is centimeters. So in this case, if we calculate the perimeter of it, so the unit stays the same. So in this case, perimeter is equal to the sum, and the fancy symbol is sigma, sum of the sides. So the perimeter, then we add up all of the sides. If we look at the big base and we measure it, we end up getting 4 centimeters. The side length, we get 3.2 centimeters. The big base, we get 6.1 centimeters. If you want to actually pause the video and calculate the perimeter yourself, you can, just so that we can speed it up a little bit. But also try it on your own, that the sum of the sides is equal to 4 centimeters plus 3.2 centimeters plus 6.1 centimeters plus 3.2 centimeters again. I add up those numbers. 4 plus 6 is 10, plus 3 plus 3 is 16. And then I have 2 plus 2 plus 1 is 0.5. A total of 16.5 centimeters is the distance all the way around this trapezoid. So just like in any other shape. Now the more tricky one is the area. So here's what I'm going to do, because it looks like if I were to calculate this like a parallelogram, if you remember the area of a parallelogram equals base times height. Well, which base do I use in this case? I have a 6.1 base and then I have a 4 base. So if I kind of maybe use one or maybe use the other one, I'm not really sure. So here's what we're going to do is we're going to make it a parallelogram. So what we'll do is I will take this trapezoid, and I'm going to double it up. So now I have two of them. Then what I'm going to do, let's just color it a little bit, just so that we can get some color in there. And then what I'm going to do is I'm going to turn this around so that one of the sides fits with the other side. Just like, not, well, let's move this over a little bit. There. So now I have two trapezoids. Now, when you turn them upside down, the two sides lengths will always fit. And now I end up getting a really cool shape again, and that's my that's a new giant parallelogram. So if I have this, if I look on the outside of this, I have now a big parallelogram. So if you remember, the area of a parallelogram is base times height. Well, this base is really the big base plus the small base because it's upside down. Whereas the other one is the small base plus the big base. So really what I'm doing now is I want to find the area of the giant parallelogram. So the area of the giant parallelogram is the big base plus the small base. Big base plus small base. And I'll put it in brackets because it is one giant base times the height still. Because it's still the same height. I didn't double that side. So let's just recap that. Area of the big parallelogram is big base plus small base in brackets times height. Now, what I do want to find, though, is only one of the trapezoids. I don't care about the big parallelogram. I do want to only find the yellow one or the white one. So what I'm going to do is then, how many trapezoids fit into that one parallelogram? And the answer is 2, just like the triangles fitting in a parallelogram as well. So what I'm going to do is I'll take the area of the big parallelogram and I'm going to cut that in half or divide by 2. So the area of a trapezoid is equal to the area of the big parallelogram, and that's what we already wrote here, which is big base plus small base times height. So this is the area of the big parallelogram, just this, and then all of that divided by 2. I'm going to chop it in half to find only the trapezoid. So this is now the formula for the area of a trapezoid, is the area of the giant parallelogram divided by 2. And the giant parallelogram is a big base plus a small base, because I flipped it upside down. So let's actually do the math here. So now I have all these numbers. The only number I don't have is the height. And if I measure it using a ruler, I get 3 centimeters. If you want to pause the video, try out the calculations and see if we get the same answer. The area of the trapezoid is equal to, open bracket, big base was 6.1 centimeters. Oops. 6.1 centimeters plus the small base was 4 centimeters. Then times the height, which is 3 centimeters, and then all of that divided by 2 because I'm cutting it in half. So the area of a trapezoid, let me find the total base then, is 6.1 plus 4 is 10.1 centimeters times 3 centimeter height, then divide by 2. The area of a giant parallelogram, therefore, is 10.1 times 3 is 30.3 centimeters squared. So that's the big parallelogram, but I need to cut that in 2 to find only the trapezoid. So 30.3 centimeters squared divided by 2. 30.3 centimeters squared is the giant parallelogram. That I cut into 2 and I get 15.15 centimeters squared. So let's just recap. What we're doing to find when we're looking at a trapezoid is that the perimeter is still the distance around and it's still in centimeters. The area of a trapezoid, however, is a little bit tricky. What I need to do is double it to make it a giant parallelogram as we found it. Add the two bases together to find the big, gigantic base of the parallelogram. Find big base plus small base times the height to find the big parallelogram. Then we cut it in half to find then only half of it, which is the trapezoid. So that's 15.15 centimeters squared. We're going to look at a couple of special trapezoids as well, and then we're going to do another video on working backwards, and then you'll be able to do some of the problems in the textbook. Great, so hopefully you understood this lesson, and see you next time.